have an equation today that's kind of unusual looking. Probably the most prominent feature of this equation is that we have a index of a radical. Normally you're used to just seeing a constant value here, a real number, but here we actually have an expression as a function of x. It looks kind of daunting, but it really, if you just stick with this rule right here, that relates rational exponents to radical notation, you'll be in pretty good shape here. Now, the very first property, I didn't write this property down, but when you have an exponential raised to an exponential, like right here, you have a base of, an exponent of x minus 1 here on the interior. And then you have a power on the outside, also power exponent or synonymous terms. You can multiply the two together. So right here, that's what happened. We multiplied x times x minus 1 to get this expression right here. All right. Now, notice that initially the bases weren't the same. We have a 2 here and a 4 right here. Okay, well, I changed 4 to 2 squared. That way we would have the same bases. Because once you do that, that makes once you have a common base, these problems become a little bit more easier to work. Now, so right here, we're just coming straight down. We see this to be true. From here to here, all I did was just change the 4 to a 2 squared. And now again, that property of exponents, which I should have written down here, I didn't write it down, but you have this power 2 right here, and on the outside you have a power or exponent of 6x. So 2 times 6x is the 12x that you see right here. Okay, now at this point, we utilize this truth that relates a rational exponent to what we call radical notation over here. This is radical notation, I suppose is what it's called. All right, and so what we do right here is we end up with this expression here, 2 to the x squared minus x all the way across just equals to this. And what makes this fly is that we have a common base here, 2, and a common base right here. Now that's exactly what I did I just came down to the next line to make it more readable. You see how I equated the 2 right here? Okay, and again, that comes from here, the work we did right here, and the work we did right here. Now, since these are what they call the exponential function is a one-to-one function, you can just equate the exponents. You see, and that's exactly what I did. X squared minus x, then x squared minus x over x minus 2. Now, oops, it looks like I made a mistake right there, folks. This should actually be, that's a typo right there. Yeah, let me circle that. That should be, let me get that fixed. It's not going to hurt the answer. I forgot to change it in one spot. Right here, this piece right here should be 12 over x. Okay. And I did correct it here in the next line. All right, but anyway, that should be 12 over x right there. Again, it's just a mistake I made. I was doing some copying and pasting to cut down on my work a little bit, and I forgot to correct that. But anyway, we get to a correct statement right here. X squared minus x is equal to 12x over x minus 2. And again, the typo happened from here, and I corrected it right here, but I just forgot to correct it right there. Now, I did leave out some steps here, but if you multiply both sides by x minus 2, you end up with this expression right here. All right, now again, I left that out just to avoid clutter, but again, I multiplied both sides by x minus 2. So x minus 2 times all of this represents these 3 terms. See that? And notice that I just have 12x here because x minus 2 over here would cancel. Now that we luckily here, we actually get 2 quadratic, excuse me, we get a cubic equation. When you collect like terms, we get a cubic equation where everything factors nicely, and we get this result right here, okay? And notice that since this is in the factored form, we have 3 candidate solutions to the original equation, 0, 5, and -2. All right. Now let's go to the next screen and let's check some of these answers. Let me clear this out here. I have it set up. Yeah, there we go. Now, y'all, this is our solution set right here, and let me. It looks like that lasted from the last screen right there. Let me. Well, I'll just leave it there. All right, just to save some time. But okay, so what we want to do is actually check. I'm going to check a few of these answers with you. All right, so I'll check it for x equals to 0. That's probably the easiest one. Well, look, I'll tell you what, y'all remember when you raise something to the 0, you get 1. So let's just walk through this. If you have a 0 right here, no matter what this part is, it's going to be equal to 1. One of the properties of exponents is anything raised to the 0. Let me write that down. Base, any base raised to the 0 power is equal to 1. Let's see if I can erase. There we go. Okay, good. All right, now, so let's check it out for something a little more perhaps involved. Let's try it out for 5. All right, so if we use 5 right here, you would actually get 2. And you know what I'm doing? I'm putting a 5 right here. So you get 2 raised to the 4th power. All right, raised to the 5th power, right? Now the property of exponents I wanted to write down, I should have written down on the previous screen, is if you have b to the m, some people call this the power of the power property. You just multiply your exponents right here. Okay, that's based just, it goes all the way back to the definition of an exponent. If you have n copies of m copies, you have m times n copies of that thing. All right, you hardly even know you're dealing with a number there. All right, so right here, this would be equal to 2 to the 20th, right? 2 raised to the 20th power on this side. Okay. Again, y'all, that's when we take this 5. We take this 5 and we substitute it here for x and just substitute it right there for x, right? 5 minus 1 being 4 right there. Okay, now we have a question. And y'all, we're not saying it's equal. We're literally asking a question. I like to say that a lot when I'm trying to explain this stuff. It's a question mark equal sign. We're asking, not asserting. So if you put a 5 right here, that would make this 3, right? And y'all, this is called the index of the radical. All right. Now, if you put a 5 right there, that would make this 4 raised to the 30th power. Okay, 4 raised to the 30th power. But notice, to make this comparable, we need to make it with base 2. So this would be equal to, now I'll go ahead and skip one little step here, but if you think about this, okay, that's the index of the radical is 3. There would be a 2 squared right there, right? But then you would multiply the power, so this would become 2 to the 60th, just to save a little bit of time. Alrighty? But remember, what does this mean? This really means 2 to the 60th raised to the 1/3 power, all right? Quite a few rules of exponents here. These are rational exponents. But remember, if you multiply 60 in 1/3, that's the same as dividing 3 into 60. And so you get 2 to the 20th. Now notice, we don't even have to know what 2 to the 20th is, but notice that that's what we got over here. It didn't take much work to get it over here, 2 to the 20th, right? Equals to 2 to the 20th. Now, just to keep the video marginally shorter, you can check out -2. -2 also works. So it's kind of interesting, this original equation with a function of x as its index. X minus 2 is actually the index of this radical, actually has 3 solutions, namely 0, 5, and -2. Okay, y'all, I hope you enjoyed. I hope that helped. Leave any comments if you'd like to see any clarification or similar type problems worked.